Well, we got a nice big bear for you today. Today's title is Verifying Inverse Functions. And we've dabbled with them a little bit in the past, at least finding an inverse function. And today we're going to just kind of move beyond that just a little bit and talk about verifying that two given functions are indeed an inverse. But first and foremost, a quick little overview of what we're going to get into here today. First of all, we're going to give you a function like this nice cubic function and just refresh the steps that go into finding f inverse. But more importantly today, we're going to kind of get into this idea if I'm given f of x and I'm given g of x, how could I prove or verify as efficiently as possible that they are indeed inverses of each other? So real quick recap here of what exactly inverse functions are. Let's just let f and g be two random functions, okay? Such that the composition here, and that's a nice spin-off of yesterday. So if I take f and compose it with g, f of g of x, the end result has to be x, nothing else. It has to be exactly x. And then if I flip the composition and I do g of f, again, the end result has to be x, or nothing more, nothing less, has to be x. Okay, so what does that look like? So if that's the case, if those two things were true, then we would say that the function g is indeed the inverse of f. And we would denote that with this fun little symbol right up here. Kind of looks like an exponent, doesn't it? It looks like f is being raised to the power of -1, but that's not the case. We don't want to interpret that as an exponent. It's not an exponent at all. It's just a symbol that we use to denote f inverse, and that's how we want to read it. Every time you see what looks like f raised to the -1, just read it as f inverse. So thus, instead of saying f of g of x, we're going to say f of f inverse of x has to equal x. And then we'll flip it around and say f inverse of f of x has to equal x. So these are two really, really nice statements that we want to pop in your notebook. All right. A couple other tidbits here just to kind of keep in your back pocket. We would say that the domain of f is equal to the range of f inverse and vice versa. And real fun image here, the graph of f inverse is going to be the reflection of f about what line? The really fun line y equals x, which is going to be this nice dotted line. Let's see if we can. So this dotted line that goes right down the center of the third and first quadrants is that line y equals x. And so basically when you're reflecting something over that line, this point right here, which is AB, becomes BA. And what we're saying mathematically is if f of A equals B, then f inverse of B must equal A. And something I think you'll hear me say down the road is, let's say, this is considered the input of f, okay? So if A is the input of f, he's guaranteed to be the output for f inverse. And then again, vice versa. If B was the output for f, then he's guaranteed to be the input for f inverse. All right, let's get into some live examples here, shall we? All right, so I've been given this cubic function, 4x cubed plus 2, and I want to try to find f inverse. So first of all, my first step is going to be real short and simple. I'm just going to rewrite that using a y. Okay. Now, the real diamond in the rough step, so to speak, is to switch those variables. So we're switching the x with the y. That's worth making a note of here. We're going to switch x and y. All right, so then all you got to do is just really try to solve for this y right here. So I'm going to subtract the 2 over, and I'm going to divide both sides by 4. Whoopsie, that's a 2 still. Got ahead of myself there a little bit. And then we're going to take the cubed root of both sides, and let's just make sure that that cubed root sign is big enough to enclose not just the numerator, but that entire fraction. And then we're just going to put the little finishing touch and make the notation real pretty. And this is going to be the inverse function right here. That's all there is to it. Now check out this next example. This next example is a really elite big time question. This is a fantastic question. So let's just rewrite the g with a y. It's a minor step that with enough practice, you can get really good and just kind of skip that step. And then we're going to switch the x's with the y. So this y becomes an x. and these x's become y. So it's 3y minus 8 over y plus 2. And then I'm going to go ahead and cross multiply. You're going to see some really nice ninja tricks here. So basically, my end goal is to solve for y. So what I want to do is I want to group all of the y's on one side together. And so what I'm going to do is I'm going to subtract a 3y. And so now I've got, let's say, xy minus 3y plus 2x equals negative 8. And then I want to subtract this 2x from both sides. So now we could say xy minus 3y equals negative 2x minus 8. Okay, now the whole reason for grouping those y's on the same side together was so we could factor out a GCF. And so we divided both of these terms by y. And then I'm just going to divide both sides by this quantity x minus 3 to really get that y isolated. So y equals negative 2x minus 8 over x minus 3. Now you'll notice there's kind of there's more negatives than positives, we'll say. So what I could do is I could multiply the top and the bottom of that fraction by negative 1 to make it 2x plus 8 all over negative x plus 3, or in other words, 3 minus x, and that's an equivalent form. So f inverse of x is probably best written as 2x plus 8 over 3 minus x. Boom. So now we're shifting gears into a slightly newer topic, and you notice this word right out of the gates, verify. So we're trying to verify that f of x and g of x, as they've been given to us, are actually inverses of each other. And so reflecting back on our notes earlier, we said basically, if they truly are inverses, then f of g of x has to equal x, and also g of f of x has to equal x. And or we kind of we graduated and we rewrote it a different way. We said f of f inverse of x has to equal x, or f inverse of f of x has to equal x. Okay, so basically I'm going to try to do two things. I'm going to first sub f into g. So I'm going to try to do this, and I'm going to try to prove that the answer is x. And then I'm going to flip the script, and I'm going to do f of g of x, where I substitute g into f. So let's focus on substituting f into g. And what I'm going to do is, let's see, I'm going to just, this x right here is going to get replaced with the quantity 3x minus 7. All right. So let's see, what if I replace that x and then rewrite the rest? So the first thing you'll see happening is the 7s are going to cancel. And then once those 7s cancel, now the 3s can cancel. And the end result is x. So we first canceled the 7s, then canceled the 3s. The answer was x. That's exactly what we were hoping for. Okay, now we're going to take g and substitute it into f, which basically means, let's see, I'm going to erase that. Okay. Now I'm going to, this x right here is going to get replaced with this function. All right, so what does that look like? So we've got the 3, and then we make our substitution, and then we just close it up and rewrite the original f. So now this time, the first thing that cancels now is the 3s. Now the 7s cancel. You're left with just x, and again, that's a good thing. That's exactly what we were hoping for. We have, because it is kind of weird the first time you do it. All right. So the first thing I'm going to do is I got to, and it doesn't matter which one goes first. You got to basically sub one function into the other. So what if I did this? What if I took this function? Let's see if I can switch colors here. It might show up a little better. Let's take this function and sub it into this x. Or another way to say that is, let's replace this x with this function. All right. So let's say the cubed root of, replace your x, and then start simplifying. So the first thing that cancels now is the 6s. And then the cubed root of x cubed, the cubes cancel, and you're left with x, which is a great thing. All right, the next thing I want to do is, let's erase those. Let's kind of start over here. All right, what if I replaced this x with this function? Okay, what would that look like? So I've got the cubed root of x plus 6 raised to the third power minus 6. This time, the first thing that cancels are these cubes. Now the 6's cancel, and I'm left with just x. How cool is that?